Hi everyone, today is Friday, and so now you're going to take out the other sheet, the one that's numbers 1 through 4. Okay, so you should start working on number 1. You're going to press pause on this. I don't think that one will take too long, but start working on that and then come back when most of you are done. Okay, so here's the work for number 1. So the radius of a sphere, so the radius is increasing at a rate of 2 inches. So that is going to be dr over ddt equals 2. Sorry for that noise in the back, that's my printer. So find the rate. So find the rate of change of the volume. So we want to find dV over dt when r equals 6. So the first thing that you're going to need for this is the volume of a sphere. Okay, so College Board should probably give you that formula, but I can't swear on that. They used to. But the volume is 4/3 pi r cubed. So we're going to take the derivative. So when you use the power rule and you bring down the 3's will cancel. And you'll be left with this. So dV over dt is what we're looking for. R is 6. And dr over dt is 2. So you're going to have, 4 times 2 is 8. Here's the pi. And 6 squared is 36. And 36 times 8 is, I don't know. I don't do it over here. 288. 288 pi, you leave it in terms of pi, and this is going to be inches per minute, but this is volume, so it's going to be cubed. So that's the answer for number 1. Okay, number 2, you're going to press this on pause, start working on number 2, and then come back and play when you're done. Okay, and you guys are back. Alright, so number 2. So all edges of a cube, so in case you don't remember what a cube looks like, each side is equal length. So we can call a side x, but you could call it whatever letter you want. I'm going to call it dx. So all edges of a cube are expanding at a rate, so dx over dt equals 3. How fast, so that's your find, is the volume changing, so find dV over dt when x equals 10. Okay, so if we need dV over dt, that means that we have to start with V. So the volume of a box, any box, cube or not, is length times width times height. So the volume is just going to be x times x times x. So the volume is just x cubed. So dV over dt is just going to be 3x squared dx over dt. Go here. So we're looking for dV over dt. X is 10, and dx over dt is 3. So 10 squared is 100 times 9 is 900, and we're going to look for the units. So it's going to be centimeters per second, and its volume, so we're going to cube it. Okay, you're going to put me on pause. You're going to go to number 3. Come back when you're ready. Okay, so now number 3. So the radius of a sphere is increasing, so dr over dt is equal to 2. At what rate? That's the find. The volume increasing, so dV over dt, when the radius is equal to 4. Okay, so we already had the volume before, 4/3 pi r cubed. Take the derivative. Okay, we're looking for dV over dt, so we leave that alone. R is 4, and dr over dt is 2. So we're going to get 8 pi times 16. So that's 128 pi. And the units is meters per second, and it's volume, so it's cube. Okay, so now you're going to press pause. You're going to do number 4. It's a really good problem. So definitely draw the picture for that and put me on pause. Come back when you're done. Okay, here's number 4. So this is a good one. All right, so we have a side of a house. So this is the ground. This is the side of the house. There's a 14-foot ladder resting against the side of the house. Okay, so here's my 14-foot ladder. Okay, one thing you need to remember is that the length of the ladder never changes. That's constant. That's going to be important later. So let's just label these sides. Let's call these A, B, and C. Okay. An absent-minded worker begins dragging the bottom of the ladder away from the house. So that means the ladder is moving here. Okay, it's moving in this direction. The bottom of the ladder is moving away from the house at a rate of 2.5 feet per second. So what side is moving? A. A is changing. A is getting bigger. So dA over dt is equal to 2.5. He doesn't notice that there's another worker standing at the top of the ladder. So that worker is standing up here. That's the top of the ladder. After 2 seconds, so this part, that's going to be important to the story. So after 2 seconds, so I'm just going to write that down, the worker on the ladder yells out. How fast is he moving down the wall when he yells? So if the worker is up here, whoops, the worker is up here. I don't know what's happening, is up here at the top of the triangle, and he's moving down. So where is he moving along? B. So dB over dt is changing. Okay, so I'll just say that again. He's up here at this point, and he starts moving down in this direction. So B is getting smaller. So dB over dt is what we're trying to find. That's our find. So find dB over dt. Okay, so just keep in mind that dB over dt better be negative because B is getting smaller as A is getting bigger. Okay, so that's pretty much what we've got. Okay, so let's start. Obviously, it's going to be the Pythagorean theorem because there's nothing else to use. So we'll start there. Take the derivative. Okay, we'll divide every term by 2. Sorry, I'm running out of room here. Okay, so now we're going to start substituting in. Let me make some room here. I'm just going to erase this part. At any time, you can pause, go back, look at it again. Okay, so first of all, we need A. So we don't have A. So we'll keep A. We need dA over dt. We have that right here. That's 2.5. Okay, plus B. We have no idea what B is. dB over dt is what we're trying to find. So that should still be there. Equals C. So C is 14. dC over dt. So what is the derivative of C? Well, C is a constant, so the derivative of C is just going to be 0. And that is going to make your life a whole lot easier. Okay, so we need to find A and B. So how are we going to do that? Well, here's where that after 2 seconds part comes in. After 2 seconds, the ladder is still 14 feet. But what happened to A and B after 2 seconds? Well, it said that originally the ladder, I'm getting a different color. Originally it said that the ladder was resting vertically against the side of the house, which means it was like this. And then over time, it started moving out in this direction. So it's moving 2.5 feet per second, that's this. Well, after 2 seconds, that will mean that it has moved 5. So A, after 2 seconds, will be equal to 5. Okay, I'm just going to go over that again in case you're confused. So here's the ground, here's the building. You have a ladder, and it's resting vertically. Maybe I should have done this in my original picture. Sorry for that screw up. It's over here. Okay, so now what's going to happen to this ladder? It's moving out like that. And then it moves out like that, and it just keeps moving out further and further. So it's moving out 2.5 feet every second. And this question is all about what's happening after 2 seconds. So if it's moving 2.5 a second, after 2 seconds, it would move 5. So I hope that's clear. Okay, and we still have a 2.5. Plus, now we need B. Okay, so let's redraw. Well, I could do right up here. So we said A is 5. The ladder is always 14. So how can we find B? Well, use the Pythagorean theorem. So B squared plus 5 squared equals 14 squared. So B squared plus 25 equals 196. B squared equals 171. So B equals radical 171. That is not a perfect square. We're just going to keep it as radical 171. Okay, let's make some room. I want to go back to the purple. This is a gross color. Okay, so B is radical 171. dB over dt is what we're looking for. And 14 times 0 is just 0. Okay, so let's multiply. 12.5. Keep everything else the same. Okay, so I'm just going to make like a little line here. I'll work on the side. I'm going to subtract 12.5 from both sides. Divide by radical 171, and you're going to get negative 12.5 over radical 171. And that's your answer. For units, we need feet per second. It's not area or volume, so we don't need, like, say, feet squared or anything like that. Don't forget, at the very beginning, we said this is all about dB over dt, and what is, let me get another color. And B is this side right here. Remember, as the ladder moves out this way, B is getting shorter and shorter, and the ladder is moving down. So it should be a negative, and we did end up with a negative, so we can feel pretty confident about our answer. Okay, so for the weekend, what I'd highly recommend is go back over these 4 problems, plus the other related rates problems, plus the ones in your Princeton review book, so you get a really good understanding, and then hopefully I'll be back on Monday, and then we can go over some more. Okay, bye.